All right, so the first things we really need to talk about, these are going to be very theoretical and completely a waste of time, but they are good to know at least.
It's recorded.
It's recorded.
It's being recorded.
Democracy.
But again, this is like base theory is usual to understand what we're working with. But you're not really going to be considering that base theory in your day-to-day work. When you're working with databases, it's just something you know is underlying all of this. And that's not even getting into the math behind databases, because they invented a version of math just for working with databases. And that, like, if you think normal math is scary where you have no numbers, this gets worse because you don't even have normal letters. They just have Greek and parentheses. So that's, we're not going to go there. So the first part is what is called the relational model of data. And this really refers to how is two pieces of data related, as the name say. So say we have a class like we have here that has some students, that would be you, and a teacher, me. So like we might have several classes here at Hack Your Future. We have a couple in Copenhagen that they also have some teachers and some students. So that means we have like, maybe if we're working with it in like JavaScript, we have like 3 different types of things. We have classes, we have students, and we have teachers. And then we also have all the people who help from home. So that's like the 3 different kinds of data we have, but how are they related? So for example, we say that, well, for each class, there are several students. In JavaScript, we would model this using an array of students on the class. But in databases, we actually also model it the other way around. Like we have both of them at the same time. So we also say that a student is in a class, which, yes, of course, but we've tried to formalize these things to make you aware of them, because they actually mean something. And they also sometimes can get a bit tricky. How are they actually related? So let's go look at if we have a class with teachers. Well, we might have actually multiple teachers in the class. That would be pretty obvious. For example, you have had both me and Marco, and I assume someone before that, Krista, I think. So that would be at least 3 of them. We're just not active at the same time always. And then we have what is the relation the other way? Is a teacher, do they just have one class, or do they have multiple classes that they can teach? So yeah, I would say go with multiple, because that would make the most sense in my head. Like if you just say you can only teach one class, and then you're never going to be in Hack Your Future again. So that would be one way of modeling it. Another way of modeling it would be saying like, okay, well, a teacher just have one class, but we have a new registration of the teacher every time, even if they teach a new class. And that again depends on how do you want to model your data. How is the relation? Is it important that you're always referring to the same person, or do you just really need to know the name of the one who was there at that time, in which case it's not important that it was actually the same person across multiple classes? So that this is called being aware of, well, how is the relationship of your data? We're not talked about what the data actually is. We're just talking about how are these things related to each other. And then we can get into how do we actually link them. But I don't think we'll get to much of that until class 2 or lesson 2. Other things you should consider is also in JavaScript you don't really worry about that much about types of things. Like we have a string and number, but most of the time we don't really care that much. You have to care a lot when you're working with a database. It's very, very important that you pick the correct types, because it'll make searching faster. It'll make it possible to do aggregations, like getting the average of something. Kind of requires that these things are numbers. It's very hard to take the average of a string. It doesn't even make sense. Or getting the max, min, or sum, or whatever. And we're not just working with something called simple numbers like we do in JavaScript. We're actually working with specific types of numbers. We're working with what we call integers, that being whole numbers, 1, 2, 3, 4, 5. And we're working with something called floats or doubles, or colloquially known as floating point numbers. That's essentially decimal numbers. And one of the things that can be kind of difficult about databases is actually figuring out, well, what is my data type? Because how should you save a phone number? We talked about this case. A phone number is not actually a number. It's actually a string. But you also have other cases like how would you save money? Say that I have a 2.5 krones. Like how would you save that? Would you save that as 2.5, or would you save it as me having, what would that be, 250 øre? Because there's one thing that computers are really, really bad at. It's actually working with decimal numbers. For example, you can't represent a third, like 1 divided by 3, on a computer. You cannot, because it's going to be 0.3333 and forever, and the computer cannot represent that. You've probably seen sometimes like a very, very popular thing that goes wrong if you take 0.1 plus 0.2. We try to do that in JavaScript. We're going to have a really fun number. .30004, because it cannot represent 0.3. This is the closest it can get, which, I mean, is still pretty close. Like we're on the 20th decimal before it goes wrong. So there are some things that you cannot be, in this case you really have to consider, well, what is my data model? Or what is my data? Because like when you're saving these things to a database, when you're creating tables to store things in, you need to know, because changing that, it can be quite difficult and quite slow. Because when you're doing this in production, usually your database is like the central point of everything that ever happens in systems. So if you suddenly need to take your database down for a day, that means everything just stops for a whole day. Nothing happens, which would be kind of bad in a web shop, for example. So don't update your database on Black Friday. That's going to cost you a lot of money. And next part, like we're going to be talking more about this as we get into actually working with the database later on. So next part is the difference between a database and a DBMS, a database management system. You can almost hear it from the name. A database management system manages databases, which means there's multiple databases in each DBMS. So MariaDB or MySQL, as we just installed, actually can have multiple databases at the same time running, which is actually quite useful. That's how Amazon, for example, can say, all right, here's a very cheap database. They don't give you a full machine for that. They might have 100 databases on the same machine. You just connect to a specific one of them. So we can also use the DBMS to do things like backups, because if our server goes down and the disk is dead, we just lost all our customer data if we don't have a backup. We can have the DBMS do that for us also. And it can also help us with things like, we're going to be looking at something called indexes later on, we can use to improve performance of queries. It can also give us suggestions for that.
Does it also, is that the DBMS that also does replication?
That depends on the database.
Okay.
For SQL Server, I think it is. For Postgres, it's not. So it really depends on the database.
Okay.
And some of these things here, we're going to be seeing that the limit or boundaries between these things are really, really soft. And sometimes they switch place, which is really fun. Specifically in this concept called a schema. So in a database, we are dealing with a couple of things. I'm not sure of the exact count. We have the DBMS, that's like the top level of everything. That manages everything. Underneath that, you might have several databases. In each of those databases, you might have several schemas, and in each of those schemas, you have several tables. And the confusing part is that some database systems switch what is a schema and what's a database around. So when you hear schema, or when you say schema, people will usually figure out what you mean from what you say after. Like schema doesn't mean anything in the database world because no one agrees on what it is. If you talk MariaDB, it's one thing. If you talk Postgres, it's another. It's what MariaDB calls a database. So, yeah. Don't focus too much on that. And then in tables we have rows, which is the next part, or entities, as some call them, which is really an entity you can look at. It's like an instance of a class or a row. It's a single value of something, or set of values that we can work with in one go. We can query it, we can change it, but this data always follows each other. And I'm not going to go into ER diagrams or entity relation diagrams because I have honestly never seen anyone ever use them in real life. They teach you them in school and you're going to be learning this and you're going to be using it all the time. No, you're never going to be using an ER diagram in the real world. Your software architect might when he's drawing out the system, but you're never going to be using it after that. It can be useful to talk about things, but because I don't really have anything that I can use to draw on right now other than paint, and you're not going to be able to see anything from that either way, we're just going to skip that for now. You can always look it up, but I guarantee you, you will not miss the knowledge. I hope that Marie will not hear this part. So now we're going to be actually getting to some fun part, actually doing something. So if you go into MySQL Workbench, the first thing we really need to do is connect to the database that we just installed. And it's been several years since I used this, so if I'm going to be looking a bit strange looking for things, that's why. So I think I called it that. Yes. So I think we can do, what is it? No, that's emojis. This? Yes, magnifier. So yes, the connection name, you can call it whatever. We usually call it localhost to mean this machine. Yeah. The host name should be 127.0.0.1. That again means your machine. Username is root, and when you go into this, you can enter in your password for the database. You don't need to select the default schema. We'll get to that. And then you press test connection. You're going to be getting this warning because we're not technically talking to MySQL. But if you just say continue, it'll tell you that it still worked. And I just hope that this will keep working. So now that we have this connection established, we can, shut up. We can double click on it and we get this very, very confusing view. So what's going on here is basically several things at the same time.
Can you just go back for, no, you can't go back.
So the first thing we need to do when we get connected right now, as far as I can see, okay, there's technically a schema called test. Down here, you can, it's just,
similar to SQL,
yes, like most of them are basically the same. Like if it works in one, it'll probably work in the other. So down here, it starts out at administration, you can select schemas, and that's where we're going to be looking at. So we create a new schema. We can give it a name. Let's call it Hack Your Future. For the charge set, you should select UTF-8 MB4, which is down there. And for the collation, just leave it default. That's going to be the easiest part.
How to create a new schema again?
So up here, there's this little this thing. When you see this icon, this is the icon for a database in most systems.
It's like a pancake, 3 pancakes with a plus.
Yeah, effectively.
Three fat pancakes.
One thing that's really, really nice about SQL, you can do everything using code. Like when you use the UI, it just basically, for now, it just shows you, for example, okay, you want to do this thing, here is what I'm going to execute as code, and then you can just go down and click apply. And it'll tell you, yep, we executed, that's awesome, finish. And then we can see we have a HIF over here. So now we're actually going to switch away from all of this right away. So the first thing and I'm gonna go completely out of order because I kind of think the order here is wrong, but that's so you have a basic understanding of what is actually going on here. So the first thing we need to do is we need to create a table. Table is where we save all the data in databases. So that is just like your good old Excel table. It has multiple columns and multiple rows, pretty much like a table in Excel or Word. So to do that, we use create table, then the table name, my table, and then in the parentheses. Okay, so IntelliSense is not going to work here. That's going to be fun. We need to tell it, so what properties should these tables have? In this case, I just want a single column. I want the name, and I want it to be of type, I think it's called varchar.
We should apply.
The what?
I can apply.
Yes, apply.
You want I do this and then.
Okay, then try going over to schemas in the side.
Was it able to get the
Beside administration, below.
Here?
No, below.
I am now.
Below, there. Up,
Oh, yeah.
there, schemas, and then you should see it there. Hack your future.
Select this.
Then just type here.
Table?
HYF.
Yeah, if you just expand, then you can see that it's there. But there is no tables yet.
No, just start typing.
Okay.
So for varchar, this is me recalling my SQL syntax from quite a few years ago. I think we can just tell it a size here. So we do varchar, and varchar is basically string in SQL language. And then we tell it, well, how big should that string be? Well, in this case, it should be a max of 60 characters. Awesome. Run it. And we should get an error. I mean, alright, double click on the schema over here. It'll actually literally tell you down here. Double clicking his name in the schema list in the sidebar will solve that little issue. Boom. And now it says, alright, 0 rows affected, but that means it has actually done something. Refresh. So you can see here now we actually have a table here that has a column name. And we're just going to be expanding on this example.
Still error on my end. What to double click again?
This up here, the schema itself, it should be bold now, and that tells it it's actually selected.
Set as default. Okay. What?
Is that not how they do it here?
And I should click save or enter or what?
That execute, that little lightning bolt.
Okay.
That'll run the code.
Oh, it's wrong.
Is it not working for you?
Yeah,
It says that the my table is created, but it's not here.
Click over here, click that little refresh button,
Okay.
and it'll reload.
Yeah.
Because normally when we're doing this, it would expect us to create them by hand, but I'm not going to allow you to get away that easy.
Because I remember one time it was just like I adding just some stuff and just boom.
Yeah, but yeah, no, we need to learn what we're actually working with. To get some data into the table, and we're only going to be learning this next lesson, but we're going to be looking at much more advanced ways of doing it next lesson. We do insert.
Can you just wait?
What?
Just wait, I think 2 seconds.
No.
Wait a second.
No. Or,
Just like, because
We'll delete whatever we.
yeah, once you have run that code, just remove it.
Okay.
So I think it's called insert into my table. Then you specify, well, which columns do we want inserted into? I want inserted into name. I want the values. And very important thing to notice is that Okay, you actually can in MySQL. Depending on the database system, what kind of quote you can use is different. In MS SQL, Microsoft's version, you can only use single quotes. And MySQL, you can apparently use both. So in this case, I'm just going to insert my name into this thing and then run it. And it'll tell me, all right, this is the query I executed, and one row was affected. So, you with me so far? All right, then I think that's how you comment out. You have the varchar spelled wrong. Is that not an E?
Like that, right?
Yes.
I tried that also.
No. So it says right here, no data is selected default to be used by double clicking the schema list. So double click on it.
Creates
And then run it.
one column.
Yes,
That was easy.
it creates a row, and then next one.
Okay, now insert.
Yes.
You should put a sharp.
That's just makes it into a comment, so it's not executed.
And insert in my table, or I insert in the column, or what?
So you say what table to insert into. In this case, the table name is my table.
Okay.
And what column should it insert? Name. And what values?
Ah, yeah, I can find.
Will it matter if we click something on the left side or not?
That depends on what you click. If you click delete all my data, then yes.
Oh, I mean, if we click on the table, column,
No.
add something?
No. This is completely independent.
Ah.
So once you've gotten so far, then we can start actually getting data. And that's the part we're going to be working with today, just getting data.
Yeah.
Getting data in 101 different ways. So select from my table. And when you execute that, you can see that you get a very, very tiny table down here. But it technically has a value.
Okay.
Can I see it up there? Yeah. Oh, yeah.
So now that we have done this, now you know how to use a database, we can go home. We don't need 3 weeks of lessons.
Super.
No, Marie will kill me if I do that.
It's still recorded.
Yep.
Now we can start.
I mean, you can technically go home. I'm not stopping you.
Now we start the kettle.
Theoretical.
So, if we want to do something with this now, we're gonna have a break very shortly. So don't start the kettle yet.
No, honestly. No, I'm not gonna do that.
So
I told you I would never
in GitHub, if you go to like today's folder, there's this lessondata.sql file. You take that, open it, and then go into raw mode, and then just copy paste this into the workbench, and then execute. And it'll run a lot of code down here, and some of it will. No, that's not. That's fine.
All of it?
Yes, just all of it in one go. And once you have done that, then delete it again.
Lesson 1, lesson data, going to raw mode.
Where should we put it? In the query one?
Just here, this, and then just execute all of it.
After the select start.
No, just remove what was there before.
Yeah. Okay.
Done.
Should execute it? Execute it?
Yes.
It takes a lot of fun working with database. More than JavaScript.
The what?
More than JavaScript.
Well, do you say databases are difficult or what?
No, I said I think it's a lot of fun working with database.
Yes, it's a lot of fun until you get into the really hairy things, and you'll be like, just give me my JavaScript. I could do this in 2 lines, not 50. And in other cases, it's completely different. You would need like 100 lines in JavaScript and 5 lines in this. So. Has everybody executed that?
I think the part that fascinates me on database is actually the relation of the data.
Yeah.
That's
So you need it's in a whole different GitHub repository.
Yeah?
Yes, and then you need to find one more databases.
Create 3 tables.
Makes it a bit easier for the basic. Then just control it.
Now we can delete it.
What?
Now we can delete it.
Yes, you can delete the text again after you run it. So now that we have some data in here, if you refresh again, you'll see that you now have several new tables. You have status, task, and user. So let's just look at what we have in the different things. In user, we have an ID, a name, an email, and a phone number. In task, we should have an ID, a title, a description, created, updated, due date, status ID, and user ID. And in status, we should have an ID and a name. So, do any of you notice anything that is shared across all of these 3 tables?
ID.
Yes. So one important thing to notice when you're working with databases, and my teacher in school is going to kill me for saying this, always put an ID on your rows, because you can technically use some of the data as the identifier. I wouldn't recommend it, because at some point all of that data will change. For example, it might be obvious to say for the user I can just use their username as the ID. That's great. What happens when you find out that that user was a curse, that username was a swear word in some language that was actually highly offensive to some specific culture? Well, then you need to be able to have them change their username, and suddenly all your data that uses that username is now wrong. So better to refer to the ID and then only have the username in one place. Because the IDs, because it's something completely arbitrary that we invented, we can change it, or we can just not change it, because it's not related to the data there at all. It's just something that we can say, all right, ID 4, yes, that's that guy. And whether or not he changes the color of his shirt, gets a new name, new email, moves to another country, he's still ID number 4. So that's like first lesson of databases. Always put an ID on your data, because it makes it a lot easier in the long run.
If I remember correctly, that also should be the primary key.
Yes, but we have not talked about what the primary key is yet. So, but today we're mostly going to be, well, the only thing we're going to be talking about is doing select statements. So basically, the first thing we're going to do is doing a basic select. So you have already seen some of a select star from, let's go with the new data we got, user. And then you can see we get considerably more data than we got before. And as you can see, some of it is actually null. Essentially meaning the same thing in JavaScript, there is nothing here. What we can do with the select, other than select star, just means just get me everything from the table. Just everything. I'm not picking here. It's very useful for debugging. You should never use it in your applications when you code, because then you probably don't want everything. And it'll also break if things rename and such. You won't actually be able to see it. So what we can do is we can say, I only want some of it. I only want the ID and the name of the user. So I do ID, comma, name. And if I execute that, I will only see the ID and the name. I can then again add in their email. I execute that, I get that also. So that's basically how you select which columns you want to work with, because when you're pulling these things out in an application, you usually only want a few of these. If you need to check the usernames, the user's user and password, you might only want their ID, their username, and their password. Like, for heaven's sake, if they log in with their username, you probably don't even care about getting their username back because you already have that. And you assume when you tell the database, I want the user that has this username, that it actually returns you that. So then you probably only want some of it. And the less data you get, the faster it is to get. Like, that's basic. Simple, less work we need to do, faster to do. Like, if you're told only to clean your table, that's faster than being told to clean your entire room. So what else can we do with a select? Like, that was the basic. But if we want to go really more complex, we can say, all right, I want all the users who has the ID 4, which means only one of them, hopefully. Otherwise, what's the purpose of an ID? To do that, we use what is called the where clause. Everything in SQL is called a clause, but where says I only want the things that matches this. It basically works like filter does in JavaScript. So and say, all right, give me everything where ID is equal to 4, and execute that, and then we only get that single row back. And here we can again do like we did before. I only want the ID and the name of that thing, and then you'll only get that. So even less data. Because imagine when Facebook queries for chat messages in their database. They don't want to always get all the chat messages from every user since ever and then figure out in their application code. They want their database to only return the last 100 messages from me if I'm requesting the data. Otherwise, it's going to be way too slow. And like Facebook, they use MySQL. Facebook, like with how big they are, use MySQL. They just have a lot of abstraction on top of that thing.
A lot of what?
Abstractions. So they don't have one MySQL database. They have a couple of data centers that only run MySQL. And then they have a lot of layers of application code that helps them figuring out which server to talk to. So if you're a really heavy Facebook chat user, you might have your own database in Facebook. Who knows? So other than selecting from ID, you can also do an OR. So we can do where ID is 4 or the ID is equal to 5. Important to note, we can't do, well, let's just show the result of this. We can't do where ID is equal to 4 or 5. I mean, I don't think that will work at least. No, it won't work. In some database systems, this will crash. That also depends on your database system. Postgres won't allow this. MySQL is very much, I'll try to figure out what the heck you meant, and then do that, even if it's not what you meant. So what really happens here is basically the same thing that happens if you do if 5 in JavaScript. It will be the same as doing if true, in which case, if we do this, we will also get everything. So just like that, we can query for, let's just get everything here again.
You can do this also.
Yeah, you can do all sorts of compare. You can do where ID is less than 4, where ID is more than 4. Guess what that will return. You can
ID.
Yeah, you can also do, and this is really odd, not equal.
I don't remember that one. Really?
Yes, it looks like that. Why the heck they decided to do that and not what everybody else is doing like this?
Yeah.
Oh, that's like I didn't.
Okay, this actually works also. But depending on your database system, this is the official syntax, which is, I don't know why. It means not equal. But if you read it, it really just says more than 5 or less than, more than 4 or less than 4, which is basically the same thing as saying not 4. Yay, computer scientist, how difficult can we make it to understand code? So let's just go with the same thing that we've used in JavaScript. not equal.
Yeah. Which is easy to read as well.
Yes, and easier to type, in my opinion. Because the thing with these characters on a Danish keyboard is that it's actually the same key, but you need to press shift to get the other half. So if you type really fast, you're just going to end up with this. And it's like, no. And you're doing a bitwise operation instead, which is completely wrong. You can do the AND. So let's just see what's here again. So I can do where there's really not anything I can do a good AND with here.
And?
Yeah. Oh, I can do the IDs. Where ID is more than 4 and ID is less than 8.
Yeah.
Then we only get that. And you can mix and match. You can also go with other columns. So you can go like and email is equal to whatever that guy's email is. Like, because emails are usually unique, that means that this one doesn't matter anymore, but it'll still do it for you. So you can mix and match multiple parameters. Next part we're going to be looking at is what is called a like statement, which is a bit more flexible than just doing less than. So say, if we take all the data again, what if I want all the people who have... There's no shared data here.
That's fine.
The what?
That's fine.
Yeah, but...
Yeah. Everybody. Yeah.
Like I want all the people who start with a P in their name.
Yeah.
So I can do where name like, which means something kind of like this, and then you can give it what is called a pattern. And patterns in SQL looks like this. Parenthesis means just anything. All right. In this case, we want P and then anything, and that will give us all the ones that start with a P. And you can mix and match these in different ways. You can also do it the other way around. You can get all the ones that end with an E, which in this case is only one guy.
If you put just E or P.
Then you would get nothing. Because then it's looking for something specifically that says E.
Yeah.
And important to notice, it's a lot quicker to look for something that just has E than it is to look for something that ends with E. Because then it actually needs to go and like look for all at the ends of all of them, and that takes more time in databases. But usually we don't worry about that because.
And if you put percentage before and after, it will just have E.
Yes, if yeah, it should.
In between.
Yeah. So the thing is, I'm not sure what happens if there's actually only an E in the end.
No, it's not taken.
No, it is taken because I think is what happened here is you see line 3.
Yeah, but they have
an E in between.
Yeah. So that will be taken, but I'm actually not sure what happens if they have a name like something like this, RB, whatever. I'm not sure if that will actually be included. Usually you'll figure these things out during experimentation. Also turns out you don't use this that often. It looks fancy then for doing some sort of searching, and you can do that. But that's really like if people have a free text search. But in most larger systems, you end up using something that's not a SQL database for searching because you want more fancy features like being able to select additional filters. Like if we go on Amazon, we want to be able to order a computer. We need to say, I want this much RAM, I want this CPU, I want this GPU, I want it to be this big. And then I want it to have this thing in the name. Okay, so then it's actually need multiple parameters. And if you throw that into a SQL, you're going to be ending up with a query that's like several kilometers long and takes forever to execute. And like no one is going to wait for forever for your database to load. People only wait for like 100 milliseconds, which is not a lot. So you don't use this much, but it's useful if you're debugging something. And say, all right, find me all the things that has this ish in the name and whatever, and then you can try look for it. Or if you're just removing data with, for example, swear words, you can go, if it has swear word in there, remove it.
But now can we add also like this one and something else? Like
yes.
How long? How we want?
You can make it just so we can do email like where the email has an S. And you can make these as long and complex as you want, but of course the more complex you make them, the slower they'll be. And like we have 20 people in this system, I'm pretty sure you cannot write a query that's going to be slow. When you have a billion rows,
Yeah.
then it's another story, because your computer will usually only execute about 3 to 4 billion instructions per second. And to do a compare instruction like this takes about 10,000. So like if you have a billion rows, it's going to be taking most of a month to execute.
Each of them, if it's true, it's been executed, yeah?
Not understood.
Yeah. If like E is true, or email like S is true, it will be executed.
If both of them are true, they will be down here. If we do...
In a row 4,
Yes.
the name is not true.
They have an E right here.
Oh yeah, yes.
What if we do OR, we will get for both of them.
Yeah.
Now, if you do N, and let's say you put on the S, you put like a hash instead. Like instead of a S, you just put like the hash number, the hashtag. Yeah.
And you will get a whole lot of nothing.
There you go. That's his answer.
Yeah.
That's your answer.
Yeah. Okay.
So that's like queries, that's how you pull data. So now imagine you have a web shop. Like the best example ever, always web shop.
What?
Like a web shop, you have worked with a web shop before. Everybody has their own web shop nowadays. Several people have multiple of them. Amazon has all the web shops at the same time. In my web shop, I have more than 20 products. I have 2,000 products. I might have 1 million products. I'm not going to be showing 1 million products to the users because they're not being scrolling through that. They're going to be going through pages of my products mostly. And it's the same thing with Google. Anything on page 2, you won't look at it. Like even if it's on page 2, it doesn't exist, basically. So how do we do paging? So say like, all right, just give me all the data. In this case, we only have 12, so that's how much do we have in task? A bit more, 35. So say that we only want to show 10 at a time. Then we can do limit 10. And boom, we only get 10 back. Easy as that. So, well, okay. But now I want page 2 of these. That's a bit counterintuitive, but what you do is you do offset. That says, all right, how much should it like offset the query before it actually starts returning data? So again, we say, all right, we'll offset it 10, and we'll technically get the same page. Page 2. If you offset by 20, we'll get page 3. So offset just say, all right, take all the data. And then if you don't have an offset, it just starts from the first one. Just blah, 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 blah. That's 10, done. Then if you say offset, it says, all right, I need to offset by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. All right, I have offset by 10 now. Then I need to start getting 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's basically what limit and offset does. And I'm not sure if you can actually mix around the order. I think you can.
But what offset 10 and limit 10? You said, okay, what is it?
So limit says how many should it return from the query at most. Even if there are more results, even if there are 2 billion results, how many should return? It should only give me 10. Or it should only give me 20.
This is the limit.
Yeah, that's just how much should it give me. I don't want more than this, because again, getting more data takes more time. And if the user is only going to be looking at the first 10, there's no reason to load the first million. So assuming that we have a limit of 10, well, now I want the next page. Because it was not on the first page we show the user, so they tell us, give me the second page. This happens a lot, that when you go to the second page of your pagination, well, to do that you have to do offset. And offset says how much should it skip before it starts returning results.
Offset, how much should skip?
Yes. So assuming again that we have all the data. So how many, because when we say, if we don't have an offset, it just starts returning from the first thing it finds. And then it says, all right, I have 1, now I have 2, now I have 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
Boom, I'm done.
That's it. When you set limit.
Yes. But then if I do offset, it will do the offset first. So it will say, all right, well, how many do I not care about? So how many should it not give me first?
Or not select.
Yes.
Okay.
So if I do offset 10, it'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. Now I have skipped 10. All right. So what did you tell me to do again? Pick 10. Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you go.
And the third should set offsets for 30 or 20.
20. Yes. Because then you want to skip the first 20. Because that was the 2 first pages. And a very tiny thing to notice here is that if you have, for example, like a where clause in here, it will consider the where clause before it actually does these. So say that we have a where title like, and then it has an, I think we're going to get a lot with E. So if we do this, we get like, still a lot.
Put another letter on the no, put 2 letters in there. Put 2 letters on the
Yes, but I want something that actually returns something. That like returns like 20 or so.
like
Percent A, percent then E.
AE.
Yeah. Hope it works.
So that gives me something. As you can see, it skipped some of them, but we still get 21 out. But again, my customers, they only want 10 at a time. So I still do that, and as you can see, it's still those that did not match. It still gives me 10. Even it gives me the first 10 that actually matches, not just the first 10, and then it throws out everything that doesn't. Otherwise, I would risk only getting 2, even though I asked for 10. And then I can do, all right, then I want page 2 of this. So I again offset it by 10. And it'll continue from there, if you will. One thing to notice is because it needs to be able to actually figure out how many to offset. That means it actually needs to do the where on all those. Even if we don't want them out, the database is still doing the where clause for them. So if you have a very complex where clause and you have an like offset 10 million, it'll still be executing the where clause on those 10 million, which will take time. So an offset is not like, yeah, free, I don't care about these. In that case, you need a better system, something like Apache Solar or Elasticsearch, which performs better for these things.
Now, you're probably going to talk about that, but I'm going to ask you now because we're doing select now. Does he, let's say, you also can add there ascending or descending, right?
Yeah, but we're going to get to those. Yeah.
Now, when you, let's say, the default is ascending. Now, when you put the descending order, will that skip all the rows and you start from the bottom up?
Yes, then it will actually execute from the back.
From the back, okay.
But like some of these things get really, really complex when you don't have when you have, for example, a joint table.
Yeah.
Then it becomes a bit confusing from what is the order.
Yeah, exactly. Yeah.
So that's like some systems you'll actually get a warning for this because I didn't specify the order of these things. So we can just go to what Ricardo asked about now. So like, what if I want these things in a different order? Right now, as you can tell, they're clearly sorted by the ID. Yeah. What if I want them in the other direction? Well, then I do order by ID. It'll still give me this because it'll do them in ascending, but then I can do order by ID descending. disk. And well, guess what? It'll be in the other direction. I can also order on other things, like then the ID. I can order on the title, descending. As you can see, then the ID is completely messed up in the order. But at least the titles are now alphabetically reverse. And same thing if I do ascending. I'll get it normal alphabetic. This also works with a limit and offset. If I do just limit 10, I'll only get the first 10 that matches. But then if I do offset by 10, it'll kind of skip to the next page still, and it'll still work correctly with this order by. One thing to notice is that the order in which we have these clauses are kind of important, even though it doesn't seem to be. Like SQL is pretty flexible in how you put things most of the time, but it wants these things in a reasonable order still. So for example, I cannot, to my knowledge, do it like this. You have to like tell it, this is how you remove data, this is how you sort the data, and this is how much data I actually want back. Because it kind of needs, before it can sort it, it needs to know what data to sort. And before it can return it to you, well, it needs to have the data sorted in some order, so it can actually figure out, well, what is the first 10? Because the first 10, if things are not in order, is kind of, then we can't kind of go to page 2 if we're going to get half the items again, because they're just in random order.
And can we be ordered by the date?
If they have a date here, for example, like created, yeah, we can do that, totally. So created. And you see we get them in order by that. And again, we can also the other direction. So if you can stuff it in a column, you can order by it. Basically, you can filter it, you can limit, you can offset, you can join on it, which we're going to be looking at in a moment. So if it fits in the database, you can do everything with it.
Can we see the data type on the created table on the dates?
I think so. So they're down here. So it's date time.
Date time.
How about we go for a small break now? Because I think I've been talking a lot, and you kind of need to cool your head down now before we go into what is going to. I think the next thing. All right, aggregations. That's not going to be that horrible. Joining, however, that's going to be where you're going to be mind blown.
That's fine.
So yeah, let's take a 10-minute break now. For that, be until 25.